This video will be about interpreting points relative to a system. So I have two big tips for this homework, and that is get context about the system. So what does each line in the system represent? And my second tip is focus on the point after that and try to figure out what the point represents, because that's ultimately what the question will be asking. So let's look at a few examples together. I'm going to go straight to the webpage so we can look at it there. So we have this first word problem. It says, and they're going to give us some information here. They're going to give us a graph down here, and they're going to give us a variety of answers down here that we can select. So I'm going to go through my process. You might do it slightly differently, but this might be helpful for you guys. So the first thing I do is I look at the graph. So I notice I have a system of equations, and I think this red line must be one equation, and this blue line must be another equation. And they actually tell me, they say line A, my blue line, is y equals 96. And this red line, line B, y equals 3x. It looks like y is some sort of cost, and x is books, it says. So maybe the amount of books. So maybe, for example, 10 books costs $30 if you're on line B, and maybe 10 books cost $96 if you're on line A. Interesting. Okay. So let's actually read what this is about. So Aiden wants to get a subscription to an online library. Oh, so like Netflix for books. Okay. There are two subscriptions, one of which charges a fixed $96 annual fee. So they're saying one subscription charges exactly 96, and that's it. Fixed just means it does not change. So looking at these two lines, maybe make in your own head, pause the video if you need to, a guess. Which line do you think represents a fixed $96 annual fee? So a $96 fee that does not change. Okay, so maybe you have an answer by now. If not, maybe pause the video. So line A is going to be that $96 fee. Because notice how if I have 10 books, it's $96. If I have 25 books, $96. If I have 70 books, still $96. So it's always $96 no matter how many books you use. Okay, and it says the other charges $3 per the book that person borrows. So if we're looking at this line, this must be the other line. They're saying if I buy 10 books, that's $30. That makes sense, right? Because it's $3 per book. If I get 20 books, well, $3 per 20 books, that should be 60. Oh, look, it crosses where the y coordinate would be 60. Okay. So basically what I just did right there was I gave me some context of the system I'm looking at, trying to understand it a little bit better. Now what I'm going to do is I'm finally going to look at my point. I'm going to look at R. What does this point represent exactly? Well, one thing that's interesting about it is it's where both lines cross each other. Maybe that's significant for some reason. So let me think about just the red line for a second. So this is my red line. And my red line, remember, is I pay $3 for every book. So if I have 10 books, it's 30. If I have 20 books, it's 60. So what this is saying is if I get somewhere between 30 and 35, so like about 32-ish approximately, not exactly, but about maybe 32 books, I'm going to be paying $96. And 32 times 3 is 96, so this is actually exact. So it's saying if I get 32 books under the red subscription plan, the $3 a book plan, I'll pay $96. Now let's think about it in terms of the blue line. So what this is saying is if I get 32 books for the blue subscription plan, I'll pay $96 as well. So this point R is interesting because, yeah, it's true, $96 always for the blue one, but it's also the one and only time for the red subscription, the one where I pay $3 per book, where it also costs $96. So this could be important if you're thinking, if I want to decide what kind of subscription do I want to pay for my books. Well, for me, realistically, in a year, I probably read, if I'm doing really well for myself, about 20 books. So for me, which of these two lines makes more sense? Well, maybe the red line works better for me because I'll be paying for less books. So I'll be paying, it looks like, $60 for 20 books. Whereas if I buy the blue plan, I'll be paying $96 no matter what. But imagine someone who reads way more than me. So maybe Miss Cobb, and let's say she reads 60 books a year. And so she could pay the red plan, the same plan that I would pay, $3 a book, but that would cost her $180, which is way more than the blue plan, which is $96. The reason this point R is significant is, imagine I read exactly 32 books. I would ask you, which plan should I use? And you might say, well, it doesn't matter. You'll pay exactly $96 whether you're using the blue plan or the red plan because you're using 32 books. And so 32 books with red cost $96, and any amount of books with blue cost $96. So R is the one point where you pay the exact same price for both sets of books. Okay, so this was a lot of me talking out loud, but this is kind of how I like to approach these problems before I even look at the possibilities sometimes. Now, if you get stuck, you may want to look at the answers first and kind of work backwards. But I would actually recommend trying to give yourself a minute to really look at the problem and give yourself some context. It does take a little while at first, but it will really build up those skills for you. So let's see what our answer is. A number of books and their cost where the subscription with the annual fee costs less. No, that's not what it is because we're saying they cost the same. So it looks like C is going to be the answer. A number of books and their costs where both subscriptions cost the same. Okay, let's try another one. I promise I'll try to go a little bit faster. I encourage you to stick around for another example, maybe another 3 if you really want to. But remember, at any point you can kind of switch modes and say, you know what, I'm going to go try the exercises. You might want to also look at Khan's example video. He has a nice short one with one example that you can check out. I'm trying to go a little bit more in depth, give you guys a little bit more detail on these. All right, so I'm looking at a graph and we have line A is 0.30 times x plus 0.15 times y equals 12. Okay, so this line is that long thing. And then this line over here is x plus y equals 50. That's line B, the blue line. So it's saying she uses a blend. So a blend means like a mixture of white corn and yellow corn to make tortilla chips at a restaurant. She needs to buy 50 kilograms of corn in her total for her next order. White corn costs 30 cents per kilo. Yellow corn costs 15 cents per kilogram. And she wants to spend $12 total. Here's a graph that shows a system of equations for the scenario where x is the amount of white corn she buys. So this x represents the white corn she buys. And y represents the amount of yellow corn she buys. Okay, so it's saying I'm paying 30 cents for each kilo of white corn and 15 cents for each kilo of yellow corn. That's what y is. And all together, when I add up the kilograms of white and yellow corn, it has to be a total of 12 kilograms. Okay. Or a total of $12, excuse me. And then this over here is saying white corn kilograms plus yellow corn kilograms has to be 50 kilograms. So just thinking about this for a second, the green line is kind of like talking about prices, right? And we have these rates next to the amounts of each thing, so that kind of makes sense. Ends up being $12. That's a price. So that gives us a hint we are looking at a price. The blue line, on the other hand, well, this represents the actual kilograms because they're saying we want to end up with 50 kilograms of corn total. So this represents this line here. And so we want to know what point E represents in this context. So if I'm looking at this graph, basically what the green line means is all the different combinations of white and yellow corn I can buy that add up to $12. So for example, I could buy 5 kilograms of white corn and 70 kilograms of yellow corn. Or maybe I buy more yellow corn. Maybe I buy 20 kilograms of yellow corn, 20 kilograms of white corn, and this would end up being 40 kilograms of yellow corn. No, that's not right. 20 should add up with, oh no, that is right. It should add up with 40. So if I buy 20 kilograms of white corn, I'll get 40 kilograms of yellow corn. And this is an issue because if you remember, 20 plus 20 kilograms of white plus 40 kilograms of yellow, that would give me 60 kilograms. That's not what I want. So there's actually, let's look at this point here. So it's saying I'm going to have 30 kilograms of white corn and 20 kilograms of yellow corn. And it's going to be exactly $12. And it's also going to be 50 kilograms. So basically, all of these points down here on the blue line are all the different combinations I could do to get 50 kilograms, right? I could have, for example, 10 of white and 40 of yellow. Or I could have 40 of yellow and 10 of white. But there's an issue. She has to spend exactly $12. And only one of these combinations costs exactly $12. Most of these combinations cost a different amount. So if I tried to do the calculation, it wouldn't cost quite the right amount. But they also give us this formula here. And this represents exactly how to get $12. So for example, you could get 20 kilograms of white and 40 kilograms of yellow, but the issue is that's 60 kilograms. She doesn't want that much. She wants exactly 50 kilograms. And point E is the only point where both of these things are satisfied. So the blue line says, is it the right weight? The green line says, is it the right price? And so E is the only one that is both the right price and the right weight in this case. So what does point E represent in this context? Well, it represents where she has the right price and the right amount of weight. So spends the intended amount of money and buys the intended amount of corn. Yes, absolutely. This one works because she's doing exactly both of those. Okay, so these are pretty verbose, which means a lot of talking and a lot of listening on your guys' parts. I'm going to try to do the next ones a little bit quicker. But again, if you have questions on these, do not hesitate to ask me. These are not easy. All right. Chana and Josiah started skating at the same time in the same direction, but Josiah had a head start at 10 meters past the starting line, and Chana skated 3 meters per second, and Josiah skated 2 meters per second. Here's a graph that shows a system of equations for this scenario where x is the number of seconds since they started skating, and y is the distance in meters from their starting line. Okay, so we're imagining two ice skaters, right? And they are maybe racing each other, they're going in the same direction. One of them is going 3 meters per second, so that's going to be this blue line. You'll notice it has a slope of 3, that's a good hint. A lot of times velocities are slopes. And the other one is going 2 meters per second, and so that's this one here. Notice it's a slightly less steep slope, and it has a slope of 2, good. And the other interesting thing is, for this equation, he starts 10 meters ahead. So this red one must be Josiah, because he has a 10 meter head start, and he's going 2 meters per second. And this other one must be Chana. She is blue, and she is going 3 meters per second. So what does this point represent exactly? So you'll notice, for example, at time 0, Chana is at the starting line. So she's 0 meters ahead, but Josiah is already 10 meters ahead. But let's move ahead in time some. Let's go 5 seconds in. So 5 seconds into the race, it looks like Chana is actually almost 20 meters. So this, I guess, would be 5, 10, 15, 20. So it looks like 5 seconds in, Chana has gone 15 meters, which makes sense because she's going 3 meters per second. And it looks like Josiah now is at 20 meters. So he's only gone 10 meters, but he started 10 meters ahead, so he's still ahead of Chana. But then if I fast forward to 10 seconds, at 10 seconds, Chana is going 3 meters per second, so she's at 30 meters. And Josiah is actually at 30 meters too, because even though he's going slower, he started a little bit ahead. But at this point in time, they're right at the exact same place. And notice what happens afterwards. Chana is this blue line, Josiah is this red line. Chana goes up ahead, so Chana passes him right at this point. And Josiah just keeps going and kind of falling further and further behind Chana. This distance between the two lines represents the distance between the two skaters. And so we want to figure out, well, what does point H represent? Well, this is right where they're at the same place, right when Chana is passing Josiah. So Chana's distance from the starting line at the time when she is behind Josiah. No, this is not the case. Josiah's distance from the starting line at a time when he is behind Chana. No, actually, right here they are both at the same place. Chana and Josiah's distance from the starting line at the time when Chana catches up with Josiah. Yes, so this is right where Chana catches up or passes Josiah. And that's why we're going to select C for that one. Let's try one more. All right, Casper has some whipping cream, delicious, that is 18% butterfat and some milk that is 4% butterfat. He wants to make a 500 milliliter mixture of them that is 12% butterfat. Oh, I've been in this situation cooking before. So like, for example, they'll say use 2% milk, and that means milk with 2% fat, but I'll only have whole milk, which I don't even remember, but maybe it's like 5% fat, and skim milk, which is 0% fat, and I have to figure out, well, how do I get to 2% fat? So this is similar for Casper. So he has 18% and he has 4%, but he has, it looks like he maybe has different amounts of them that he's gonna have to use, because he wants to make half of a liter, so 500 milliliters. That is exactly 12% butterfat. Here's a graph that shows a system of equations for this scenario where X is the volume of the whipping cream he uses and Y is the volume of the milk he uses. Okay, so X is the whipping cream, Y is the milk. So the whipping cream is 18% fat and the milk, the Y, is 4% fat. And what this equation says is some amount of whipping cream plus some amount of milk should give you 12% times 500. So if I combine these amounts, this should give me to 12% of some kind of mixture. So when I want this 12% butterfat, I need to combine some amount of 4% milk and 18% butterfat. What this other line down here says is I have X is whipped cream and Y is milk. I need to add some amount of whipped cream to some amount of milk to get exactly 500 grams. So this line B we can interpret as weight, right? It's saying the weight of the whipped cream plus the milk needs to be 500. And this one we can consider as the percentage of fat, right? It's saying we need to end up with 12% of fat mixing some combination of 18% whipped cream and 4% milk. And so this is interesting. Before we've had point L exactly kind of like on the line there, but L is off the line here. What's going on? And so let's think about this. So point L is not the right weight. It's not on this line, which is all the solutions for the correct weight. Point L is also not the correct percentage of fat, right? These are all the possible combinations that would be 12% fat. And so L is neither one. It doesn't really satisfy either condition. Now, let's kind of consider it. This one is weight. So this is saying they add up to have 500 of exactly 500 weight. So I could have, for example, 500 milliliters of cream and 0 milliliters of milk. And I've been using the word weight. I should use the word volume in this case because unlike water, milk isn't technically exactly 1 gram, 1 milliliter. It's very close, but not quite. So we'll say milliliters. So in this case, I could have 500 milliliters of cream. I could have exactly 500 milliliters of milk with nothing else. Or I could have a combination of two. So I could have, for example, 250 of cream and 250 of milk. That would add up to 500. I could have maybe 300 of cream and 200 of milk. That would work. Any of these along this blue axis work for weight. But this down here, I only have, well, let's see. I have less than 400 of cream. It looks like I have 350 of cream. And it looks like I have 150 of milk, or I have 100 of milk. So 350 cream plus 100 milk, that only gives me 450 milliliters. So I have less milliliters than I need. Okay, so I have less volume, less milliliters. And let's look at what it means relative to the red line. So The red line represents where you have 12%. And when you add extra cream, you get fattier things. And when you have extra milk instead, you'll have less fatty things. And so in this case, I'm adding extra cream, so it's gonna be above 12% butterfat. So I'm gonna have above 12% butterfat, but I'm gonna have less than 500 milliliters of volume. So it has more than the intended volume? No, it has less than the intended volume. The mixture has less than the intended volume, and it has more than the intended percent of butterfat. So D is going to be the answer to that one. Okay, so again, this one is a tough one. Please email me with questions as you have them. You might need to practice these a few times in a row, but you will get the hang of these eventually. They are tough though, so if you've stuck to this point in the video, good for you. If you have any questions, email me, or come to the class video chat Friday at 12. It's optional, but I encourage you guys to come. If you have specific questions, I can answer those. If you just want to go over some more examples in general, we'll have those too. So that's the time to do that. Here's the previous topic if you need it. I know it's kind of a slog and we've been working really hard on word problems recently, but we will be not dealing with as many word problems very soon. So stick in there this last week with lots of word problems. All right, that's it for this time, and I will see you guys later this week.